This video is showing a tool that's generating the production data of standard handrails. Depending on the project, the tool covers between 70 and 90% of the handrails. The tool is not limited to a specific type. The only limitation there is that it doesn't cover fillings, but it handles both continuous and interrupted rails. And as the basis of the test, it uses a library of handrail type definitions, and each type definition contains a definition of the section, design rules for the type, and a library of typical posts and ends for that type. As all tools of that type, the tool has two functions. It has a check function and it has an export function, and I will start with the checking right away. We have to load data into the tool by updating. The data is basically, it's a list of display classes used for the parts in the model, for the visible parts, and of that display classes we have to select the ones that don't hold secondary parts of the platforms, like the flooring or handrails, safety gates, or whatever. So here we have to select the platform parts, press check, select the parts that we want to check, and enter. The check function of the tool has two parts. In the first part there are general tests done. The group structure of the model is checked, if all parts are grouped, if there are no free subgroups existing, if parts inside of groups collide, and also, the allocation of display classes and area classes and of the material. Then the tool is analyzing the bolted connections. It creates sets of bolts with the bolted parts and it's checking them. It's checking if there are conflicts inside, if the holes don't match, or if the bolts collide with the bolted parts. At the end of the first part of testing, an error list gets filled that shows the user what error were found so far. And there are two types of errors that the user has to fix. That is, if there are collisions inside of handrails and if there are problems with the bolted connections. All the other errors that may get listed, the user either can decide to fix them or not and can continue with testing. If the tool doesn't find any errors, then it's just continuing. We'll see what we get as a result of the first part of the checking. So here we have the results, and we have errors that the user has to fix. The tool has show height functions and marking functions that help the user to navigate, to find the parts. And if we look here, we have problems with holes and bolts, and we see that the hole field is moved, so we just correct that. And look at the second error type. The parts that have problems always are shown white, and here we see we have a collision of the rail with a post. We move the rail in Z direction. And that should fix it. We have to recheck now. Start the check again, and we will see what we get as a result. We still have errors. We could continue with the check, with the second part of the check, but we will have a look what errors we have. Here is a collision obviously between the plate and the beam that should get fixed. There we have minor collisions between a kick plate and the angles that connect the kick plates to the post. So the kick plate would just move a little bit to the outside. That's not a problem. Same situation here. But here we have a collision between the handrail and the beam of the platform that would move the handrail to the outside and would cause a conflict here. So that should get fixed. But we don't care about that. We'll continue with the testing. And now the handrail is starting with the connections between the handrail groups and the platforms. These are the base plates of the post, so it's starting with them and it's getting the post parts, it's restructuring, it's editing the group structure of the handrail group, it's creating subgroups for the posts and for the ends, and it's checking the geometry of the rails. It's checking if the subgroups match template groups for the handrail definition that it found. That's basically defined by the section that is defined, is given by the rail geometry. And then it makes overall geometry tests. You see that the handrails get colored, the sequence of posts in one field of a handrail gets colored, and we'll see what we get as the result of the test. We will get lists of standard types in here, and also if there are handrails that are not standard handrails, we get not standard handrails here, and for the not standard handrails we will get a list of errors why they are not standard handrails. We have the list of standard handrails, we have straight handrails, and I'll show what they look like. Straight handrails and L shapes, U shapes, and non-standard handrails. So far the types of standard handrails are limited to straight handrails, L shapes, U and Z, and the L and U and Z shapes may either have 90 or 270 degree angles. And if we look for instance at the U shape here and look into the group data, we see that the group got an entry in the node 1 field of the group properties, which says standard part, the type it's a handrail, the handrail type name, and the subtype. And if we look at one post for instance, then we see the post also got an entry in node 1 of the group properties, typical part, the handrail name, and the post type. Let's look at the non-standard parts and the errors for them. What errors do we have? For instance, no bolted connection to platform. Okay, I mean this part doesn't even have a post, so it's not connected to the platform. Or bow radius. Here, that's the radius of bows is just not matching the design rules for the radiuses. Not all parts used. The tool could not use the post parts. Let's see why. Yeah, we see that there is obviously no beam, so the posts are not connected to any steel part, to nothing. That's, I mean, that has to get fixed. Then for instance we have no typical post. These posts should be typical because they are posts for safety gates, so they are just not matching the definitions, the typical parts, and that can get fixed definitely. Also, if there are posts in there that are not typical but that occur quite often, they could get included in the library of posts that's part of the handrail type definition and increase the amount of standard handrails found this way. Then we have, for instance, no standard type definition existing. That is that these two handrails, they match all criteria for standard handrails, but there's no definition existing for them. And the reason here is both are L-shaped handrails, but the angle between the two fields are neither 90 nor 270 degrees. So they are just not standard handrails. I will position the parts now. I'm gonna clip that and then I will continue with the export. Positioning is done. These are the group numbers for the bigger assembly. I use 2 number ranges and we can continue with the export now. I have to select use post numbers, also post number root, and we have to add a project number to be able to export. Select the parts and enter. And now the tool is rechecking the parts. It's checking if the parts are standard parts, still standard parts. If necessary, it's editing the entry in the node 1 field of the group properties. Then it's checking if the allocation of the post number types is still correct. And if that's the case, then we can continue with the export. The tool is creating the system drawings by copying the templates, it's generating the production data, it's filling the tables of the system drawings, and it's finally editing the title fields of the drawings. All the user has to do is save the drawings and the production data is generated. No detailing, no creation of detailed drawings of handrails necessary for the standard parts. Let's see what we have. We have a couple of drawings. We have, for instance, these are the straight handrails of the bigger assembly. We got 2 sheets with tables. You see we have representation of the part with all the necessary dimensions and labels. And we have a table that contains the group data, the name, the number. Then we have the dimensions for the group and we have the dimensions for the parts. We have the posts and the ends used, and very important, we have a sketch that shows what the handrail has to look like. It shows the proportions and also it shows the individual parts like the base plates of the posts, parts that are added to the posts or the ends. These sketches help the shop to make the handrail. What else do we have? That's an L-shaped. We see that we need 2 tables. One table is for the dimensions of the group, for the 2 fields, and we also have a sketch here. And let's look for the U-shape. Here we have the part, then the table, the dimensions for the groups, for the 3 fields of the U-shape. We have the sketch that shows what the handrail has to look like, and we have the data for the single parts. So that's the tool to create the production data for standard handrails. There are videos for other tools of that type on our webpage. There's also contact information in case you like to get in touch with us.